Alright, hi guys. Gonna learn a little bit about renewable energy sources. So we just did all of the non-renewable things that don't come back or come back very slowly. And then we're gonna move on to our renewables. So I'm gonna go over just a few of them today. I'm not gonna do all of them on here, which is nice. So we're gonna kind of just chunk it up a little bit. What I like about doing this is this gives you an opportunity to listen to me. So as I'm speaking, going through the PowerPoint, so that way if you just want to sit back and listen instead of reading, that works. But you'll also get just the PowerPoint without the video aspect in case you would just like to go back and read. There are also videos in this PowerPoint which are extremely useful. I highly recommend that you watch them, because I'm not going to watch them with you. That would take too long and kind of be weird. Alright, so you'll get two versions of this, the version of me speaking over and then the version that is just the PowerPoint on itself, so you can go back at any point. Alright, so we're going to go through two of our renewable resources, things that come back. Always a problem. Alright, so difference between non-renewable and renewable source. So a non-renewable energy source, the ones we looked at before, like coal, oil, natural gas, and nuclear energy, disappear. Once they're all used up, they're going to be completely gone or take way too long to come back. Like, we know that oil and coal takes millions to millions and millions of years to be created, so there will be more eventually, but we're using up too much energy. It's not coming back fast enough for us, right? So we want to focus on things like renewable energy. That's plentiful, and that is constantly around us, right? So here are examples of renewable energy sources. We have solar, we have wind, hydroelectric, geothermal, biomass, and hydrogen. We're going to stick mostly with these up here, the solar, wind, the hydroelectric, geothermal, biomass, okay? Again, I'm only going to go through two of them today just to make things easier for us. And after I go through this, there will be a question on Google Classroom for you to kind of answer based around our notes for today. Okay, so let's start with one of the two I want to go over. So hydroelectricity. Hydro. So that's an important kind of prefix of a word, meaning water, right? If you see anything with the word hydro in it, it's referencing water. So hydroelectricity, getting electrical power or any kind of power from water, specifically flowing water, right? So right here is the video, the YouTube video that I'd highly recommend that you watch. Shows you that here we have a reservoir full of water. It's going to flow downwards and it's going to turn this turbine, right? So it's flowing water. This accounts for about 16.6% of the total world's electricity. So that's not a lot. I mean, we are a water-based planet. We have lots of this. So hydropower can be a really good option for a lot of like coastal places, right? Or anywhere that has a large waterfall or a large dam that can be built from any type of river flowing water. So only about 17% of the world is using this great resource that is very plentiful. One of the major hydroelectric plants in the United States is at Niagara Falls, which makes sense, right? So a large dam is holding all this water, and it's allowing someone to flow through, which turns the turbine and generates electricity from the generator. Right? So just kind of like what I was saying, how does it work? Water turns a turbine, which turns a metal shaft in an electrical generator, which is the motor that produces electricity, right? So all this water comes in, turns the turbine, and then is turning this generator, powering and creating electricity, which is then sent through, like electrical cables to wherever it needs to go. We had talked about turbines before with non-renewable resources, but the difference between that and this was with things like oil and gas and coal. We were burning something, right? So we were burning all this resource and it was turning a turbine, generating this generator. And creating electricity. And that burning aspect, that burning part of that resource was the problem, right? Because it released that CO2, that carbon dioxide, or even worse, different kinds of chemicals into the atmosphere, causing lots of problems, right? So this is not burning anything, right? We're simply just taking water that's just moving from one spot to the other spot, and it's turning that turbine, right? So that's nice and safe. So, some advantages and disadvantages. Advantages. Small scale does not impact the environment as much as large scale impact. So it does have a small impact on the environment still, depending, because we are changing the way water moves, so that can disrupt some ecosystems, which is not great, but it's not too terrible, especially if you can plan it out appropriately. It does not produce air pollutants, like I said in the last slide. We're not burning anything, so there's nothing going into the atmosphere, which is awesome. Year-round water supplies. So water doesn't just disappear for a portion of the year, right? It's always there. It's always going to be moving and flowing. So it is a year-round supply, something that can be used all the time. Great. Disadvantages. Like I said, it can disrupt water flow patterns, so that can end up disrupting ecosystems, affecting migration routes, right? Like a lot of fish migrate back to where they kind of spawned or grew up, so that kind of change can disrupt them, causing issues. And also can affect precipitation patterns. Now, that word, precipitation, if we remember, means some type of rain, right? Sleet, snow, water coming from the atmosphere down to the ground. So it definitely is going to affect that, because if you are moving water sources around, that means you're also moving where the source of water is going to go back up into the atmosphere or come back down. So there are some disadvantages. It's not perfect, but it's definitely better than burning anything, right? So that's just hydropower. So hydro, water, power. Wind. Wind's another good one, right? So wind energy, pretty simple. Use of airflow through wind turbines to mechanically power generators for electrical power. So here is another wonderful, amazing video. Amazing, that we definitely should click on when you have a chance and watch. So wind energy is actually super awesome, because just like water, wind is all around us at all points, right? There's air flowing constantly, so it's a wonderful renewable resource. We have wind farms. They consist of many individual turbines. These can be found in places that there's like a lot of airflow. So like, again, near the coast, right? Because the ocean creates these air currents. So we see that we place like a lot of these air turbines in like one area to really maximize the amount of power we're getting from there, right? A good example of this is back near my old hometown of Atlantic City. They have lots and lots of wind turbines near there because it's right on the coast. So it's very fair. And this is kind of what it looks like. So see, here's this giant wind turbine, right? And these blades here catch the air, right, the airflow that's coming, and turns the turbine on the inside. So airflow passes the rotor blades, these big white blades, on the tower and turns the blades. The turn of the blades turn the generator, which creates electrical energy. So as this giant thing is turning, there is a motor on the inside, and then the electrical power is created and then transported down and then out to wherever the electricity needs to go. So they're actually really cool. It's really awesome. Useful. So, advantages. No fuel, right? It's just on airflow. So as long as there's nice windy days every now and then, wonderful, excellent. No harmful polluting gases. Again, we're not burning anything with wind energy. We're simply just using what's already here with airflow. And can generate energy for thousands of homes. So like one of those turbines actually generates a lot of electricity. So when you find a spot that you can put a lot of those turbines, imagine the amount of energy you can capture, right? Especially if we have a lot of these wind farms. They're just very useful for generating a lot of power. Now, again, not everything's perfect. Some disadvantages. It's going to be they're a bit noisy, all right? That turning giant tower does make some noise. And people feel like it spoils the view of wherever they're living, meaning, you don't want to wake up in the morning and just see this giant metal tower, right? A lot of people like to wake up, maybe get a nice view of the ocean or these beautiful mountains. They don't want to see this big noisy pole with spinning blades. So a lot of people are a little angry if they get built near a very scenic area, right? If there's no wind, there's no energy. So if for some odd reason there hasn't been a breeze in a little while, well, nothing's going to happen. So you are heavily relying on this air current, and sometimes there's not a strong enough one. So, I mean, it might not actually generate any electricity. And then costly to install. So, as much as renewable energy sources are amazing, they can be pretty costly to create, right? The parts for it in general, to install, for having people who have to go out there and fix things, right? You have to have actually specific people who know what they're doing. You can't just have any maintenance person go and fix the giant wind turbine. It has to be someone who has engineering skills, and that's going to cost money. They're very, very large, and that's a lot to install, so that again is going to cost lots of money. So it becomes difficult because we know our non-renewable resources are very cheap. Our renewable resources are a little more expensive, so a lot of people don't like putting out that extra money. They'd rather stick with the cheap stuff, right? But we got to go toward this stuff. All right, that's all I'm bothering with you for now. Wind and hydroelectricity power. Please watch those 2 videos. They're very, very short, right? They will help further explain these 2 sources of energy. I would like you to go back onto Google Classroom. There will be a question for you to answer based around wind energy and hydropower. Okay? Hope everyone's doing okay, staying safe, and I hope your spring break was a good one. All right, guys? Until next time.